Yes, write down thermodynamic system. Last class we did work done is 2.303 log of V final upon V initial, or nRT log of V final upon V initial. The graph of PV is called as isotherm. A few more theoretical things, then we'll see derivation. Define thermodynamic system. The collection or group of objects, the collection or group of objects that can form a unit. The collection or group of objects that can form a unit which may have ability to exchange energy with its surrounding is called as thermodynamic system. So they can ask in exam, what is thermodynamic system? It is collection or group of objects that forms a unit which may have ability to exchange energy with surrounding is called as thermodynamic system. So anything which is under consideration and can exchange the heat is, in short, thermodynamic system. Right, definition. The collection or group of objects that forms a unit which has ability to exchange energy with surrounding is called thermodynamic system. The collection or group of objects that can form a unit which may have ability to exchange energy with its surrounding is called as thermodynamic system. Completed?
Wait.
In very simple language, if I say my PC and writing pad is my system and anything which is outside that is called surrounding. Can I clear this now?
Yes, sir.
Arshita, written thermodynamic system. Definition: the collection or group of objects that can form a unit which may have ability to exchange energy with its surrounding is called as thermodynamic system. Shall I clear? Arshita? Arshita? Next. Thermodynamic surrounding. This is very simple. Anything which is not the part of system is called as surroundings. It is not the part of system is called as surroundings. or environment. Anything which is not the part of system is called as surroundings or environment. Yes, you can. There are three types of systems. First, open system. There are three types of system. First one, open system. Open system means the system can freely allow exchange of energy and matter with its environment. Suppose there is water boiling in kettle, then heat will go to the air. It is kept open. It is exchanged with the surrounding. That is open system. So if I keep the container open and something goes in the surrounding, that is called open system. So a system that freely allows exchange of energy, that is heat, and matter. So when water boils, water particle goes up. So also matter is traveling heat ke saath saath. A system that freely allows exchange of energy and matter with its surroundings is called as open system. A system that freely allows exchange of energy and matter with its surrounding is called open system. Second, closed system.
Sir, we can't hear you properly. Some disturbance is there.
Yeah. You can see this now. A system that freely allows exchange
Yes,
of. Just write that. Just write that much. Then when there is no disturbance, I will speak. Tomorrow I will shift my location. A system that freely allows exchange of energy and matter with its surroundings is called as open system. Written? This much written? Is it audible now properly?
yes, sir.
Yes. See, which is closed system, then it will give heat, but not the matter. That means particle will not move. So if I have a water closed in a container and a heat, the water will boil, but it will not leave the container. That is called closed system. Closed means it is not allowing mass to travel, only heat can be exchanged. So a system that allows exchange of energy but not matter, exchange of energy but not matter, is called as closed system. Then both open system, closed system.
Yes,
Third one, isolated system. Isolated system. Have you seen thermos?
Yes, sir.
Yes.
Will it cool the material taken inside, or hot will remain hot?
The hot
Hot will remain hot.
That means it is not exchanging heat energy with the surrounding.
Yes, sir.
And after some time, that content, suppose I have kept tea in that, will it reduce or it will remain same?
Same.
Same. So neither matter nor heat has been exchanged in the surrounding. That is called isolated system. So a system which neither allows energy nor matter to exchange with the surroundings. To exchange with the surroundings is called as isolated system. Right.
पीछे ठीक है देख जाए ऊपर देख लीजिए खुलेगा अपने कंप्यूटर को
Yes, done.
Yes.
वन का लेंगे
Okay.
वन में सिर्फ हमको मशीन पकड़ना और ये टाइट किया हो ना तो 120 टाइट है उसको फिक्स हो गया
Next one.
दीजिएगा टाइट करके हमें पाना चाहिए
Define first
वो वाला पाइप
mechanical equilibrium.
कितने वोल्ट है 1 मीटर
Last class I explained you thermal equilibrium. Whenever equilibrium, then I said something is balanced. So whenever it is mechanical, it is related to force. So when net force at any point in the system is zero, then system is said to be in mechanical equilibrium. What is zero in mechanical equilibrium? What is zero in mechanical equilibrium? See on the screen I have written. What is zero? Force. That means forces are balanced or unbalanced. If net force zero, then they are balanced or unbalanced. If net force is zero, then it is called balanced force. So what is mechanical equilibrium? A system is said to be in mechanical equilibrium if net force at all the points in system is zero. A system is said to be in mechanical equilibrium if net force at all the points in system is Done?
Weights. Done, sir.
Okay. Second, chemical equilibrium. Chemical equilibrium. When chemical composition remains same at all the positions in a system, then it is said to be in chemical equilibrium. So whenever we consider a container, every point of container will have same chemical composition. That is called chemical equilibrium. Right. Two more equilibrium. Third, which already I did, thermal equilibrium. And fourth is thermodynamic equilibrium. Thermal equilibrium. If temperature at every point in a system, if temperature at every point in a system is constant, then system is said to be in thermal equilibrium. Thermodynamic equilibrium. A system in which all the three, that is all the three equilibrium, that is mechanical, chemical, thermal, exists. is called as thermodynamic equilibrium. Right. Done?
Yes, sir.
Yes, sir. Done.
Okay. Now see, one process we did yesterday, that was which process we did last class? Thermal equilibrium process or isothermal process. Now today we are doing what is meaning of isobaric process. Bar is actually unit of pressure. So when we say isobaric process, then it is constant pressure process. So it is a constant pressure process. The boiling water at constant pressure, that is at atmospheric pressure, is an isobaric process. Pressure constant, isobaric process. The PV diagram of isobaric process, PV diagram of isothermal is called isotherm, but for isobaric process it is called as an isobar. Write this much. It is constant pressure process, boiling water at constant pressure, that is atmospheric pressure, is an isobaric. PV diagram of isobaric is called as isobar, called as an isobars. Done.
Yes, sir.
Okay, now we'll see its graph. PV graph. V, P, pressure is constant, but volume is changing. V final, V initial, pressure initial final, both are same. So AB represents isobaric process. It is called isobar. For an isobaric process, neither change in energy nor Q, neither delta U, comma Q, comma W are neither, or we can say isobaric process, delta Q, comma delta U, comma W, comma Q are all not equal to 0. In isothermal, delta U was 0. Here nothing is 0. Draw a graph and below that write this. For isobaric process, neither delta U nor Q nor W, nothing are 0.
हाँ यार ये एकदम देखो क्या दिले मारा दूंगा कि ठीक है नहीं
Yes, done full.
Yes.
Next one. Apply law of thermodynamics to isobaric process. Consider applying first law of thermodynamics here. Law of thermodynamics is first law of thermodynamics. We have to find what is dW, what is change in internal energy. Total is called total heat supplied. Consider an ideal gas.
There is a lot of disturbance in your background.
That's why I'm not telling anything. See, I'm just only writing. And that noise, please overcome that. Only I'm writing. If you go through it, I think it is simple. I'm not that's why speaking anything. Now see, consider an ideal gas undergoing expansion at constant pressure. Therefore, delta P is 0. This much clear? Consider
Yes.
okay. Is this much copy? Moment there is no voice, I will speak. Let Vi, comma Ti be completed full. Consider ideal gas undergoing
Yes.
expansion. See, I'm interested in work done at constant pressure and change in internal energy. So work done, comma W equals to PdV, which is P into final volume minus initial volume. That is same as P. Hello?
Yes, sir.
PV, can I write nRT?
Yes, sir.
So this can be written as nRT final minus T initial. So either you write in volume or you can write in temperature. Right this much? Work done is P into V final minus V initial, or PV is same as nRT and RT final minus T initial. Please write once and practice. Very simple topic. Only the thing, it is so many things are involved: pressure, volume, temperature. Change in internal energy. Delta U is N times CV into delta T. That is N times CV into T final minus T initial. So, according to first law of thermodynamics, U equals to delta U plus W. So this is N CV T final minus T initial plus NR T final minus T initial. N CV plus NR T final minus T initial. Therefore, N into CV plus R T final minus T initial. CV plus R, can we write CP?
Yes.
So this will become N N times Cp into T final minus T initial. And we also know heat supplied at constant pressure is nothing but NCP dt. By using first law also we got same. NCP dt is T final minus T initial. Now only two are left out. Isochoric, that means constant volume. Adiabatic, constant heat. Its applications are deleted from the syllabus. Done full?
Yes.
Yes, sir.
One last write down. Third one, isochoric process. Isochoric process. The process in which volume remains constant is called as isochoric process. The graph, the PV graph is as shown. V initial is same as V final. Pressure is changing from initial to final. So this AB is a graph at constant volume. Here work done W equals to 0. Completed?
Yes, sir.
Okay. By first law of thermodynamics,
Hello?
one second. 10 seconds. By first law of thermodynamics, delta U plus W for isochoric process, W is 0, so Q equals to delta U, that is N CV delta corp. Done?
Yes,
So that's all for today. One more lecture. Tomorrow this will get over. Then we can complete MCQs of this part. So entire 11th